All right, geometry. So this begins our talk on 3D figures. So again, beware. Uh, your computer screen is two-dimensional, right? Paper is two-dimensional. We are trying to create 3D figures in two-dimensional spaces. So it can be difficult to visualize these things. So just do your best. Okay, that's all you can do. Just do your best. All right, so this is what we call a polyhedron. Um, it is a three-dimensional figure, right? 3D. All of its surface are polygons. Each polygon is called a face, right? So there's faces. An edge is the segment joining two faces. And then the vertex are all the points in the corners where the edges meet. All right, so that's just breaking down what makes these polyhedrons. I'll just call them 3D figures. They're also called solids, right? Solids, because we will get into cylinders, cones, and spheres, and those are really not technically polyhedrons because their faces are not polygons. They involve circles. So 3D solids is what I will default to. So we're going to talk about cross sections. So a cross section is an intersection of a solid and a plane. All right. And you can think of a cross section as a very thin slice. So a cross section is a very thin slice of the solid. Okay. So in this picture here, they have a triangular prism. It's a triangular prism because you have triangles as the bases, and then and there's two of them. This plane is vertically cutting through this triangular prism. So what it does is when it cuts through, it cuts out this thin slice of triangle that resembles the base. So the cross section here would be a triangle. Now again, this is super, super hard to visualize. So I will do my best down here to show you. Typically, when you cut a solid, you do it vertically or you do it horizontally, okay? So in this picture, this is a triangular prism. Again, two triangular bases. So if I take this prism and I cut it vertically, right? Say I cut it vertically. That means I'm going to go parallel with the bases. When I cut it vertically, I'm going to hit the top edge there, the bottom edge there, and the bottom edge somewhere there, right? And again, what you're going to create is you're going to create a triangle that resembles the base. All right. So again, when you go parallel with the bases, so this is parallel. Here, let me do this better. Let me just use the symbol, right? Parallel. You know, parallel means the double parallel to the bases. You are going to be the shape of the base. Now let's go horizontally. Now, if I cut this thing horizontally, it's going to hit this edge here, this back edge here, this edge here, and this edge here. And now if I connect those, now I get a rectangle. This is what I would call being perpendicular to the bases. And we'll learn later that because this is a prism, prisms are made up of the shape of the base and rectangles. So if your plane is cutting your bases, then the shape of the plane or the shape of the cross section will be a rectangle. Okay. So again, I'm doing my best to do this in 2D space. So now let's look at a square pyramid. So we'll also talk about pyramids. Now pyramids only have one base. So this square is the base. Now again, say I go vertically. Okay, let's go vertical. Let's go right to this tip. Let's go through this space, through this edge, to that edge. Now you're going to create what's called a triangle. And again, the reason is this one is going to be perpendicular to the bases, perpendicular to the base. And when it's perpendicular, notice I get a triangle because of a pyramid and the fact that pyramids meet at one point, so the other faces are triangles, unlike prisms, which had rectangles. Now, what if I go horizontal, parallel to the base? Well, it's going to touch this edge, this edge, this edge. And if you connect those, you're going to see that, oh, I'm just going to be a smaller square. So if I go parallel to the base of a pyramid, I'm going to be the shape of the base. Okay? So again, think to yourself, am I parallel with the base? Oh, it's going to be the shape of the base. Am I perpendicular to the base? Well, if it's a prism, then I'm going to be a rectangle. If it's a pyramid, then I'm going to be a triangle. Okay. All right, so do your best there. I know it's not easy. And then the last thing we'll talk about are these solids of revolutions. So you can take a plane region and revolve it about a line to create a solid of revolution. So it's where you take a plane and you revolve it about a line. Now, when you think of revolution, you should think of circular motion and circles. Okay? So for instance, let's take this rectangular region right here and let's rotate around L. Okay? Well, this point right here is going to rotate. This point here is going to rotate. And if I connect these, because all those points are going to rotate too, hopefully you can see that you do get this cylinder. So a rectangle will produce a cylinder when you rotate it around a line. Now, what about this triangle? Well, this point right here is going to rotate down and back up. But this point will stay here, but all these points will rotate like this and like this. And if you connect them all, you get the cone. So when you have a triangular plane region, you're going to get a cone. And now what about a half circle or even a full circle, right? Well, again, all of these points are going to rotate. All of these are going to rotate. All these are going to rotate. And if you connect all those, sorry about that, I did my best, you get the full sphere. So if you take a semicircle or a half circle, or even a full circle, and you revolve it, you're going to get a sphere. So keep that in mind that when they talk about solids of revolutions, they should involve circles. Okay. All right, cool. So let's go to edge elastic and do a couple questions, or maybe just one question, I think. All right, so this is a cross section. It says describe the cross section, and notice I say spelling counts. So again, if you look at this yellow figure is a cone. And a cone is a pyramid with a circular base. So right now, the two 2D shapes I'm thinking about are a circle, which is the shape of the base, or a triangle. I don't need parentheses, or a triangle. Because again, a cone is or resembles a pyramid. So the way that this cross section is going down is it's going vertically through the base. So it's touching here, it's touching here, and it's touching somewhere over there. And guess what? When I connect those dots, I get this cross section, which is a triangle. So it doesn't matter if it's capitalized or lowercase, just please don't misspell triangle. Now it says visualize a plane horizontally cutting this cone. Describe the shape of the cross section. So again, if I try my best, here's my circular base. Here's my cone. So let me take a different color. Let's go horizontally. So we're going to cut here, and we're going to cut here. And again, because of its circular nature, instead of using straight segments to connect those dots, I'll use curves. And you can see that what you're going to get when you cut that cone horizontally, you're going to get another circle, just like the shape of the base. Okay, so hopefully this video helped you understand or start visualizing 3D and cross sections and solids of revolutions. So again, this chapter is much more focused on volume, which will be the next 4 videos and next 4 sections. Okay, all right, great job. Only one video for this section. Tune in for your 11.4 coming up next.